Uh, Hello everyone. We are back with another episode of True ML Talk. This time we have with us Hien Luu, who is the senior engineering manager at DoorDash, leading the build out of DoorDash's ML platform. DoorDash, as everyone knows, is one of the biggest companies in the food delivery space in the US, more than a $25 billion company. And we are pleased to have Lian with us today. Lian, welcome to the show. We'd love to hear a little bit more about the journey of DoorDash through the ML side. Like, what really prompted DoorDash to start using ML? What were some of the major use cases, and what was the impact on the business that you all kind of foresaw that you all invested so much into building out of this platform?
Yeah, absolutely. We are essentially a technology company in the space of logistics, and we have a marketplace. And ML plays a pretty big role across the different product lines that we have on DoorDash. But some of the use cases are, you know, quite that are obvious and standard, similar to other internet companies. For example, like search recommendations, ads and promotions, and fraud. A few areas that's specific to DoorDash, essentially logistics, right? How do we assign orders to dashers? How do we predict how long does it take to prepare food? And then routing the dashers. So those are fairly specific to DoorDash business. So there are a mix of general ML use cases, but there's also a subset that are very specific to the logistics business essentially. And then the other ones would be in the areas of in terms of detecting, classifying menu items, because we onboard a lot of merchants and they have their menus. So how do we help with that to make that process seamless? So it's quite fun because it's interesting, a good mix of a diverse set of ML use cases at DoorDash.
Awesome. I think that's great to hear. Yeah, and just for the context of the readers, it might be good to kind of get a sense of what is the scale of the platform that you all have built. What is the kind of number of orders you see on a daily basis? What is the number of requests that flows into the platform and that the models are serving, so that people can fathom the scale at which the platform is supporting the use cases?
Yeah, we obviously the platform has been built incrementally over the last 3 years, and as we work with various teams, then more and more models being onboarded to the platform. In terms of the some specific number, which I believe I have shared on my blogs, uh, across the company we would say about 300 models that's in production from the various teams, and the feature is it's getting pretty huge now. For some of the large use cases, I think in the billion in terms of feature values. And then in terms of the predictions, the number of predictions, it's also getting pretty huge too. I think we're talking about billions and billions per day across all the various use cases. So it
Wow,
has
that's
been pretty fascinating in terms of how the, the, the number of use cases that we able to support and the scale that we are able to build our infrastructure to support those. So um, very happy with the kinds of impact that we help making for the company. And I think one thing that the team's really proud of is what we build. The platform that we have now support many teams within the company, uh, and it's good as also a lot of challenges because of that diversity.
And when you say different teams, are these all ML specific teams, or do you also use the platform for say non-specific ML cases, just for normal service deployments, etc.? Curious to hear, like,
For us, the majority of them would be product teams, right? That are building external facing products, that are applying machine learning. The one that I mentioned that search recommendations, uh, logistics, and so on. So these are all product engineering teams, and ML plays a pretty big component across DoorDash products. Even on the back end engines like the logistics engine, which is mostly back end, but there's a lot of machine being involved to optimize all kinds of routing and prediction of ETA and stuff like that. So
Got it. Here, like just before we dive into different aspects of the platform in more depth, it might be good to kind of talk a little bit about how the journey has been from start to now, like in the last 3 years. How has it been incrementally built? And what were the fundamental principles like you had in mind when you started building this platform? Because by 2020, DoorDash was a pretty big company, so I guess you already had a sense of the amount of requests that will go into the platform. So you'll all have put in a lot of principles in the beginning. I saw some of them in your blog and your talks. So love to hear like how did you kind of think about those principles in the first place?
yes, the journey is quite fascinating. I wouldn't have predicted it to be this way as since day one. Oftentimes when you started out that you want to build an ML platform from the ground up, you want to have a sense of what are the pieces and how to build those pieces out in a orderly fashion. Um, but at DoorDash, our journey is quite different. uh, well, let's start with the principles, right? At the highest level that I mentioned in the past, in the blogs and various talks. The first one is think big, but start small. Obviously, you want to have some sense of directions of what it is that you want to build, but you want to build it incrementally and align with the business needs in such a way that you can demonstrate impact and result in a short amount of time, right? That's one approach. The other approach that probably won't work at DoorDash is, go and tell our customers that, hey, wait 6 months or a year, come back and we'll be able to support you. That's probably not going to work, at least at DoorDash culture.
Right.
The other one is along with that is the 1% better mentality. We recognize that what we build today is not going to be a perfect solution. It's sufficient to, solve certain needs and use cases. And we should be constantly looking for ways to improve it as we move forward. And the last principle is it's all about our platform is only as useful as it's able to support the business needs, right? The business goals. I think we have heard this many times in the blogs and various best practices. Is to best align with what the company's needs and use cases and build out solution in an incremental fashion. So our journey started out with actually we started out building out the model prediction platform first, right? Other people might start with like feature engineering, for example, but we started with the model prediction. Why? Because at that point in time, the logistics team, which is and was and still is one of the first teams that leverages machine learning a lot. And this is at the beginning of the pandemic, where the growth was growing quite rapidly at DoorDash, and their prediction service had a tough time uh, catching up with the growth, and they need a solution that's more scalable. So, and that's at the same time when my team was found and started. So with that opportunity, we jump in and partner with that team to build out the model serving platform.
Mm-hmm.
And then and once we accomplish that, they will onboard a use case. And then we gain some trust within the company as well as able to make incremental impact. And then other teams started involving us in helping them in terms of model predictions. Then we work with a search team, right? Another highly visible but also very complex and demanding in terms of requirements of latencies and whatnot. And then we did that, and then next we work with a recommendations team. So it has become like a snowball effect because we're able to demonstrate impact and trust within the company. So So that's the way when I look back at that, it was wow. I did not anticipate that, uh, uh, but that's how it turned out. And start building out the other pieces of the platform.
Got it. Maybe Ian, talk a little bit about the impact you actually caused to the logistics team and the last mile delivery. What was the impact you really saw on the business side? That kind of led DoorDash to investing further and further into ML in a huge way, right? Probably the journey of ML for you all started a bit later, but you all ramped up really, really quickly. So you would have seen significant business impact. So just want to kind of maybe quantify that for one of the teams and for the users to get a sense. Yeah.
Yeah. So for different teams within DoorDash, I think the impact is slightly different. And the impact could be in a few dimensions, right? It could be the business, revenue, it could be about efficiency, it could be accuracy, it could be customer experience, okay? So for the logistics, it was a lot about efficiency, right? As we scale up and support more and more customers and orders, how do we efficiently route those orders to the right dashers at the right time, right? So reducing the amount of time it takes to deliver an order, okay? So that has impact on both the customer experience because they can rely on the ETA that we would provide to them, and it also improves the customer experience because if they can trust that, then they can order more. I hear stories from other folks that they order food from other places and the prediction's way off, and they're not going back. Right? So that's an example of impact on the customer experience.
Yeah.
That has indirect impact on the bottom line or revenue for DoorDash. Um, for like search and recommendation, that certainly has put a direct impact on the order volume. Because
Mhm.
if you're able to find food that you like quickly and easily, you're gonna order it, right?
Right.
So that's a different kind of impact.
Right.
And then on the fraud side, it's more about reducing costs, right?
Mhm.
So the sooner they can detect fraudulent transactions or reduce the amount of issues on the platform, then that will reduce the costs on support side, for example. So it's been fascinating to see the different kinds of impact that ML can make to a company like DoorDash.
Amazing. Amazing. Maybe given you started with the model serving layer, maybe we can start with that as what was the architecture behind the model serving layer, and how have you built it to enable it to support billions of predictions on a daily basis, and how it has evolved over the years, and what would you change if at all? So maybe we'll start there.
Sure, sure. Um, yeah, there's a few key aspects, and some of the early on decision that really been the key driver for the growth, and I can share some of those. The first thing that as a company, we did not want to support all kinds of libraries or model types. We really settled down on just like GBM and PyTorch,
Okay.
right? For tree based and deep learning models. And we say, okay, these are the only two types of model or libraries that we support. What that enables us to do is really build optimized solutions for those libraries or model types. Because we want because if you want to support all kinds of library, then it's going to be very challenging for a small team to build optimal solutions, right? So that was one of the key decisions that was made early on to just focus on those two things, two libraries. And then as part of the building of the design decisions on the model serving platform, some of the key things are um, one of them it's about support batch prediction
Hmm.
because we know that these kinds of use cases uh, making network call is expensive. We all know that. And these use cases typically like recommendation, for example, they make thousands of ranking, for example, for a single person when they come to the homepage. So supporting batch prediction is also another key design decision on the model serving platform. And then the third thing is about velocity, right? How do we support making sure that data scientists can test the model easily in production? And that's done through model shadowing. So they
Mm-hmm.
can shadow the model, uh, deploy it in a shadow mode, so they can get a sense of how it works to gain confidence before they promote to production. And that helps with velocity from data scientist perspective. And the last thing is, a model serving platform is essentially like a microservice. So there's no surprise there. But I think another boost that came from early decision was to leverage the C++ layer of PyTorch to give us an additional performance in that regard. Yeah.
Got it. So, just a little bit diving into like what did you build it on top of? Like, I'm guessing you all built it on top of Kubernetes. Maybe describe a little bit of the internal architecture of the model serving layer, and then I want to deep down a little bit into the shadowing and the canary part as well.
Yeah, so the model serving platform essentially are a set of microservices. Uh, DoorDash is like most other companies are running on their infrastructure on Kubernetes. So we run our services on Kubernetes essentially, and DoorDash has standardized on Kotlin as the language, and gRPC as a protocol. Uh, so that helps too in terms of the JVM language and the binary protocol for service to service. And so that's like the core infrastructures that our platform is running on top of. And some of the things that were helpful to scale and to support these various use cases are leveraging Kubernetes way of organizing them in isolated fashion, right, into different pods, for example, and scale them separately based on the needs and such. So that's just, I would say that's pretty standard for people that are using Kubernetes and building microservices.
Right. And curious to understand like why the gRPC protocol layer, like a lot of companies that we see, they still prefer to use the HTTP and the gRPC, like people find it hard to set up. Like what was the reason for using the gRPC as a standard protocol across the company?
I would say a couple of things. One is like we all believe that when you do things at scale, right, every little thing matters, and I think the binary protocol, it's good for that when you start operating at scale. Uh, and gRPC has been battle tested at many companies, and so the risk is pretty minimal, I would say. So a combination of stability and efficiency, I think that makes a lot of sense that we adopt that as in the company.
Got it. And a little bit on the shadowing part, like you mentioned, like the shadowing, like really led to like a speed of velocity in terms of testing out and then rapidly deploying these models to production. Maybe give a an understanding of how you all build this shadowing layer, and how was it say different from like a general canary testing, and like what impact did it have in terms of the velocity, how many, like how did it enable data scientists to test more models? It'll be really good to kind of hear more on how you supported that and both them.
Yeah, I'll start with kind of the way it works, and then we can go into the other parts. It's not that at a high level, it's not that complex, but the I think the way that we made it so easy to shadow models, that I think that makes a big difference, right? And the way that's deployed is through like configurations and a simple tool to provide that configuration. So you can have what do we call it called primary model and also shadow models, and you can easily say for a certain amount of traffic, 1% or 2%, that you want to be routed through that to that shadow models. So data scientists only have to like provide those couple pieces information, and then they click a button, and then the rest of the platform will take care of that, right? In terms of load that model into the right pods, start routing certain amount of traffic for that model, and then ensure the logging, the prediction logging for those shadow models. Because that information is critical for the scientists to understand how the model is working. So that end-to-end flow, that it's not terribly complex, but we got to a point that we made it so easy and for data scientists to just do it. Obviously, when you over scale, then the amount of logging over time becomes a challenge. uh, keep that we gotta keep that in mind for some of those, especially when you have more and more models, and then when your traffic increases over time, then it can become a challenge in terms of overloading the logging system, or the cost becomes a bit too much.
Right.
But I think bottom line is we made it very easy for data scientists to do this without jumping through hoops, without involve any other engineers, right? They have total control, so they can just do it whenever they want to or need to. So,
Got it. And before I kind of go further, I wanted to kind of highlight a little bit on this point that you mentioned, giving data scientists the full control. Like today, like as we talk to a lot of companies, what we realize that a lot of data scientists, they are obviously not aware of the engineering side of things, and they want to be on the side where they are just kind of testing models, right? Like and then there are ML engineers or the platform engineers building these platforms, and I've seen like companies where there's a huge boundary in terms of what data scientists have access to or ability to do. And given, like you mentioned, this like being able to enable the data scientists to do it freely, I want to kind of just take a look at the entire stack and what were the parts where you all enable data scientists to do things freely, even if they did not have understanding of the infrastructure layer. Like would be great, and what value did you see out of that, versus like say creating an obstruction in terms of certain pieces of information or certain pieces of access.
yeah, at the highest level, our focus is about helping data scientists to apply machine learning as fast as possible, right? Going from idea to production. So that's kind of where we're operating from. Uh, so when we look at tooling infrastructures, how does that play into that velocity story? And how does it play into like self-service? So the more self-service, it helps both sides, right? The data scientists and us. The amount of hand holding we have to do because we're a small team. So automation is a very important aspect of that. That helps increase velocity, but also help reducing the workload for the support for the infrastructure team. So that's where we're operating from, and there the common approach is like building abstractions, right? Just have an abstraction so data science can express what needs to be done, in feature engineering or model training, for example, and then let the infrastructure takes care of the the engineering aspects, managing the resources, scheduling it, and whatnot. Um, so that's where I see the boundary between the infrastructure team and what the data scientists.
Right.
Um, and at least at DoorDash, I don't know about other companies, that we want to empower data scientists to do all this with minimal needs from another engineer. Because some other company, they might pair like, I don't know, another engineer to work with data scientists to onboard everything into production, right? And we want to reduce or minimize that as much as possible. and therefore data scientists can go through that iteration on their own as quickly as possible, without dependency, without like conflict, without scheduling, and get those resources to help them. So that's the way we think about building our infrastructure. Is with that in mind.
Awesome. Let's go into the the training side, like which is very interesting with the huge scale of the feature engineering store that you all have in house. Maybe give a sense of how the training workflow looks like for a data scientists, and how do they provision resources? What are the restrictions? Where do they kind of log the models? Where does features come into the play? Maybe take us through the entire training pipeline, and also give a sense of the data warehousing layer that you use. I think probably I saw you all use Snowflake, but would love to hear maybe details starting from there.
Yeah, yeah. Let's start with the feature engineering side, and then that feeds into the model training. Um, so first is the feature engineering infrastructure. At the lowest layer, like you mentioned, in the early days, we started with Snowflake as the data warehouse, which is great for storing a lot of data and easy to manage and all this stuff. Uh, but one of the things that I'm sure you know is when you're operating at scale for model training, uh, getting data out of the Snowflake is not that efficient. So one of the things that I pointed out and advocate for is, hey, we need a data lake, right? It's a good, it's a best practice, and I learned that from my days at LinkedIn, because we build
Yeah.
like a data lake in house, and this has power many kind of use cases. So that was one of the things that I advocate for, and obviously it doesn't just happen overnight. It takes time and effort. So once we got to a state that we have a decent data lake, then we started building out feature engineering framework, and that typically means a level of abstraction for data scientists to express how they want their features to be computed. And then our infrastructure will take care of running the computation, scheduling those pipelines, and managing the resources to do computations on the behalf of data scientists. And then work with the data lake team to figure out optimal format to store those in, and so on. So that's the feature engineering side.
Just before going into the training, like a little bit into the feature engineering, like how did you kind of take care of different sorts of data formats, like the streaming data or other formats of data, and between the online and the offline feature store, was it the same feature store serving both the the training side and the production side? How did you define that, and what was the architecture behind that?
Yeah, yeah. Good thing that you reminded me to talk about the online feature store. I think the feature store side I didn't mention from my previous part, but m- pretty much most of the use cases that I mentioned earlier are essentially what they call online predictions, because they are integrated to the production systems. So there's a need for an online feature store. So we have essentially both offline feature store and online feature store, like most other companies. And and I guess to kind of tackle the training and serving SKU problem that pretty well known in the industry. And like most other solutions, the way we do that is through generate the features and then store that on the offline store, and then have a mechanism to upload that same feature set onto the online store. So that way the features is generally using the same sets of logic for both offline and online, essentially. That's also where the feature engineering framework comes in to make that process that simple, right? They can say, hey, I want this in offline and online, and by the
Yeah,
way, I want it to upload uh, every Tuesday or whatever it is,
right.
and then the infrastructure will just take care of that on their behalf.
Awesome.
And they don't even have to think twice in that case, right? So
Awesome.
that's an example of building abstractions that enable data scientists to express what they want, and then the infrastructure will take care of the underlying mechanism to do that.
Awesome. Maybe let's proceed to the training side. Like once the features have been built, how does the training workflow look like?
Yeah. The first thing that I tell data scientists, you can explore all kinds of models you want on using whatever we provide, right? Whatever library that you want, you can go at it. However, the moment that you want to productionalize that model, here's the path. And here is what we require from you, which means two things, couple things. One of the first thing is you have to use like GBM or PyTorch if you want to productionize your model. Uh, so that's the requirement from the infrastructure side. And the other thing that we want to solve for is like reproducibility, which is one of the best practices from CI/CD and DevOps, right? Uh, it's not that hard to do that, but it's just like something that you need to recognize and build infrastructure to make that happen for a company and a team. And they all recognize it's important to able to reproduce models, right? Because data scientists move on from one project to another, or either that or they leave the company. So a good way to do that is to have some kind of a model training script that they put together with some underlying libraries that we provide to abstract the way how models are trained, where the models are actually stored, and to standardize the configuration of a model. So they use our library to do that. But for most of the training, the hard workhorse of training is on relying on the actual PyTorch model libraries, right? Um, so all you need to do is just submit a model training script into into a GitHub repo that we provide, and then we have a service that will pick it up and then train a model, and then save the output to some model store that we have with certain configurations that we agree on. And then we send out reports and whatnot in terms of how the models are trained and whether it's a failure, and we notify them and such. So that part is uh, that's what we currently have, but I think there's a lot of room for us to improve in that space. Um, so yeah, that's kind of our.
So question in the model training side, like the data scientists, they would be training these models. I'm guessing they are spinning up, instances, pods over Kubernetes, and they are running this training slide, right? Like if any of this training fails, like a lot of times the logs are not well saved in Kubernetes. So how do you kind of handle that, and how do you kind of notify data scientists? Like what have you done to kind of make the debugging process of that really simple?
That's a great question. That is an area, like I mentioned, that's one of the things that we need to get much better at in terms of debugging ability. Right now, it's not as easy as I would like for data scientists. um, Also, we are we are evaluating Ray to help with this as well. I think it has some mechanism to help us with the logging and stuff like that. So we're in the middle of this, and hopefully in the next few months, we'll be able to share more in terms of the progress on this side.
Would love to dive a little bit now into the part regarding the model validation. Like say data scientists train the models, and then before deploying, they are doing some sort of a shadow testing with a already existing model in prod by routing traffic, and now they are deploying it in prod. Like what are all the mechanisms that are there at each stage for the validation of the model or for the evaluation of a model, and then how does that kind of kick in to kind of either automate the retraining loop or maybe give signals to the data scientists to then do it manually? Maybe would love to dive into that a little bit.
Yeah, you pointing out a very key aspect here, and this is an area that that's work in progress, and I would love for us to get better as well. Currently, a lot of this we rely on the data scientists to do this, but I think there are more and more innovation in this space that we can help incorporate into an infrastructure to help the data scientists. Obviously, the basic thing that we have is using MLflow for help tracking with experiments, so they can evaluate, compare between experiments, and so on. So that's like a very easy thing that most companies can do out of the gate without a whole lot of effort. But in terms of like the next level of doing the model validation and then model retraining, it's an interesting topic that you brought up. And this is one of the, I believe, we're going to work on that extensively in the second half of this year and early next year to make this happen. And the way we think about it is we want to build model retraining with a lot of safeguards such that those models can automatically, if and when they meet certain criteria or threshold.
Hmm.
And we want minimum human in the loop as much as possible. That's our goal in terms of building out the continuous model retraining initiative. At a high level, it seems very simple, right? Why can't it just retrain and push to production? But different models have different needs, and different models have different consequences when something goes wrong. So we gotta take all that into consideration and build it in such a way that is flexible with safeguards, and then enable data scientists to decide on what threshold to specify, if and when to promote and not promote, or do something else when it does not meet their criteria, right? So that's what we want to build out in the next, I don't know, 6 months to 9 months.
Right. Maybe dive a little bit here on the model monitoring side, especially the drift measures and how it has been helpful. I remember a talk you all had with one of the monitoring companies. So want to maybe double down on the area of how do you all kind of enable monitoring in some way.
Yeah, our model monitoring, it's in an okay state. We providing the basic stuff that the data scientists need in terms of detecting feature drift and model drift and so on. With basic capabilities, that's also an area that I would love for us to get better at moving forward as well. Easier at in terms of onboarding, customization, right? Because different model they need slightly different customization of generating their own metrics. Uh, and then the other thing that comes to the picture is scale, because you're talking about like, because it all derived from prediction logging, and if there's no efficient way of storing and analyzing those predictions, billions of them, to generate these metrics, then that would delay the process. Um, I've been telling my team that's a gold mine there that we have, but we're not currently really mining them. We barely scratched the surface in that space. So I would love for us to invest in building that out a little more extensively over the next 6 months to a year. I envision an environment, a state where at DoorDash, data scientists can slice and dice the model prediction logging by market or by certain segments of users to analyze the model performance. That's the ideal state that I'm thinking about, but we're not there yet.
Got it. Understood. And here, maybe as you kind of build this platform, there would have been different constraints and different challenges you would have faced, either from a perspective of cost, resources, performance. Like maybe throw a list of some of the challenges and how did you think about those challenges at what point in time. Would love to kind of deep down a little bit, and if maybe you can take one of the major challenges and share how you kind of actually solved it, a real use case, that would be great.
Yeah, uh, that's a great question. There are many constraints. I'll mention a few one, and I'll deep dive into one of them. Obviously, all companies going through a bit of a tough time in recent years or last year or so. So the number of team members, the number of people on my team. We would love to get to have more engineers, but that's one constraint. But we have to operate within the company's boundary, and it makes sense. But one area that we've been focusing on and doing really well is efficiency, and specifically around cost. And we've done a great job in investing in just enough manpower with meaningful impact in terms of reducing the um, compute costs for our model serving platform. Because as you know, these are microservices. They run in 24 by 7. Uh, and the more hard compute resources you use, the more cost there is, right? So how do we look at the efficiency usage of these compute resources based on the traffic patterns? So recent time we started doing auto scaling on our model serving uh, pods or Kubernetes pods based on the traffic, and it has been pretty impactful in terms of reducing the costs. Right, that affects the bottom line for DoorDash. So that's one thing that we invested in. It's not part of building infrastructure. But efficiency is a pretty key aspect when you start operating at scale. When you're operating at small scale, then it's not that big of a deal. But when you start operating at scale, uh, like us, and well, compared to other companies, we're still small, but we're still pretty sizable in terms of scale. So that's one area that's been pretty fascinating in the last 6 months.
Awesome. Just to take a turn off, we kind of covered different parts of the stack. Uh, Want to understand here, like with the generative AI boost that is there with the chat gpt and the llms coming into the place. I remember you mentioned about ray. How does that impact, how you do ml? Like what are some of the use cases that you start to see, being used within DoorDash of generative ai, and is that like a major part of the roadmap, and how does supporting an llm based model versus like a normal ml models that we have been kind of talking about differ, and what are some of the decisions you are taking internally right now around that?
Yeah, this is one of the hottest topics in town, right? LM and generated AI. And recently, we published a blog that talks about the potential use cases for generative AI in terms of DoorDash marketplace, and the various things that we want to do with that. A lot of it's in the content generation for like menus or notifications, and so you can read more on those blogs that was published. But from my team's perspective, is a lot of it is like learning and catching up with what's out there. This space is moving very very rapidly. Like the number of open source model is popping up every day, almost every week. But as a team, what we want to figure out is what do we need to build to support data scientists in leveraging LLM. They come. There's multiple parts, right? One is prompt engineering. How do we help with that as an infrastructure team? And then uh, obviously there's some cases that we're gonna need to host those LMs internally for whatever reason, cost, privacy, whatever it might be. So we're trying to learn how to host them internally, and trying out different GPU configurations and whatnot. So working with GPU is also very fascinating because these LM models need GPUs to reduce latencies, right? So that's been fun to learn all that in a short amount of time. So we're still in the early days, but it will definitely be one of the areas that we need to invest in for the ML at DoorDash and the ML platform team to figure out what are the necessary infrastructure to support the various use cases that we have in mind. And I think that most other companies are doing the same thing.
Right.
It's just like figuring out along the way. That's part of fun. That's part of fun in this space at the moment. It's exciting new technology. As also new ways of figuring out what needs to be we need to be provided to data scientists. So I'm looking forward to it though.
Okay, one question around this is you mentioned around supporting the deployment of LLMs internally for privacy reasons. Like, is this like a very important part to be able to host LLMs internally, or do you also foresee like you all using open AI APIs or without the need for hosting? Like, and this is more from perspective of what do you think other companies will also do along these lines?
Yeah. Again, it's still early days, but I think based on what we're learning out there and understanding what's going on, there's going to be some use cases that can leverage open AI for their needs. There's going to be some use cases that will require um, internally hosted LLM models. That's what we believe based on what we kind of learn from what's going on out there. I think in 6 months I will have a much better answer
Got it.
for you than right now. Right now it's more about this is what we figured out so far. That's based on what the learnings from out there. But it kind of makes sense, right? If you think about for some use cases where latency is need low latency, where you have some your own data set that you want to use, and as you think about the scale again, the scale you operate at, where's the cost going to be like? Are you going to use an externally hosted model? So that's what we believe, but whether that's going to be true or not, is time will tell.
Got it. I think we have been hearing from a lot of companies we are talking to, especially around hosting of LLM models. And the challenges regarding the GPU and the resources management, and the need for the security and the privacy concerns. So hopefully, like we'll probably see companies like working more on the resource management side to be able to host this in a scalable way. And also the second part is the quantization of these models, being able to host different quantized versions so that so
Opportunity for startup to go in and help solving those things, and that would make it a lot easier for other companies to adopt LM.
awesome. Any last thoughts, here in terms of anything from DoorDash's ML journey that you have for other companies that are starting to build or adopting to the new trend in AI? Anything that you would advise?
Um, I don't know. Personally, for me, it's just like I feel I have a great job. I this is a great, exciting area, and building infrastructure in a space that is evolving rather rapidly. So there's a lot of to learn, but at the same time that we're able to make meaningful impact to the company. So for me, it's both of those come together. It's a very exciting space to be in, personally.
Awesome. Thank you so much for being with us. Really appreciate the same. It's great to know about the impact ML has on DoorDash, and hopefully this inspires a lot of readers to kind of either take up careers in infra or think about infra from a central principles perspective related to DevOps, SRE, and hopefully build good systems that can enable large scale ML. So really, thanks a lot, Hien, for sharing all the views. We'll look forward to speaking to you again soon.
Thank you for having me.